Okay, another example. Find g of x and h of y for the joint density function of the previous example. Here, the distribution of g of x is given by the integral of from negative infinity to positive infinity of the joint distribution of x, y with respect to what? To y. So, since our interval of x lies between 0 and 1, we shall use it, and then the joint function was given as 2 out of 5 into 2x plus what? Plus 3y with respect to what? With respect to y. This supposed to be g of x. So our g of x is equal to when you integrate this one with respect to y, we will get 2 out of 5, 2xy. So 2 times 2 will be 4xy out of 5. That's what you get here. Plus 3y squared divided by 2, which is 3y squared divided by 2 times this 2 out of 5. So when you substitute for y equals to 0 to 1, you will get 4x plus 3 out of what? Out of 5. So for x in the interval of 0 to 1, and g of x is equal to 0 elsewhere, you will have this as the marginal distribution of what? Of x. The marginal distribution of y, which is g of y, is also given by the integral of the joint distribution with respect to x. So the marginal distribution of y is equal to integral between 0 and 1. Remember, our joint distribution function was 2 out of 5 into 2x plus 3y. This time we are integrating with respect to what? To x. Hence, when we substitute for x equals to 0 to x equals to 1, we shall get 2 out of 5 into 2x squared over 2 plus 3yx. Hence, our solution will be equal to 2 out of 5 plus 6y out of 5. So this one is the marginal distribution of y, whereas this is the marginal distribution of what? Of x, when the joint distribution is 2 out of 5 into 2x plus what? Plus 3y. Let x, y be two random variables, discrete or continuous. The conditional distribution of the random variable y, given that x is given by the joint distribution of f of x, y over the marginal distribution of x, provided that this distribution is above 0 and the conditional distribution of f of x given y is equal to the joint probability distribution of x and y divided by what? By the marginal distribution of y, provided y is 0. What is statistical independence? Statistical independence refers to a situation where if for any joint distribution f of xy, okay, it's defined by the product of the marginal distribution of x and the marginal distribution of y, we say that they are statistically what? Independent. Now, supposing we have x1, x2 up to xn random variables which are discrete or continuous, with their joint probability distribution as f of x1, x2 up to xn, and their marginal distribution as f of x1, f1 x1, f2 x2, up to xn f of xn. Then, if they are statistically independent, then their joint probability distribution is equal to the product of their individual marginal what? Distribution, which is equal to f1 of f of x1 times f2 f of x2 times up to f of n xn, respectively. The random variables x1, x2 up to xn are said to be mutually statistically independent if and only if their joint probability distribution is equal to the product of their individual what? Marginal probability distributions for all x1 within their range. For example, given the joint function f of xy, which is equal to x into 1 plus y squared divided by 4, where x lies in the interval of 0 to 2 and y lies in the interval of 0 to 1, where 0 is elsewhere. They say find the marginal distribution of x, marginal distribution of y, and the conditional probability distribution of x given y, and evaluate the probability that x is between 1/4 and 1.5 given that y is equal to what? To 3. Solution. For us to get the marginal distribution of x, we need to integrate the joint probability distribution with respect to what? To y. Hence, our joint distribution is x into 1 plus 3y squared over 4. We are going to integrate with respect to y over the interval where y is 0 to what? To y equals to 1. Here we shall have xy out of 4 plus 3y squared x out of 4 for the interval of y between 0 and what? And 1. So this one is going to be x over what? Over 2. And the marginal distribution of y is equal to the integral of the joint distribution of x, y with respect to what? To x, which is equal to the interval when x is 0 to x equals to 4 of the joint probability distribution x into 1 plus 3y squared over 4 with respect to what? To x. Hence, we can, when you integrate with respect to x, you get x into 1 plus 3y squared times 2 divided by 4 into 1 plus 3y squared. Hence, hence our marginal distribution of y is going to be equal to 1 plus 3y squared over 2 when you substitute x, the interval x between 0 to 2 in this expression, you will be able to get 1 plus 3 what? Y squared over what? Over 2. Thus, using the conditional density definition for x between 0 and 2, our conditional distribution f of x, y is equal to x over what? Over 2. And our probability that x lies between a quarter and a half, given y equals to 3, is just going to be equal to the integral of x over 2 in the interval of x from a quarter to what? To a half. Remember, x over 2 is the conditional distribution of x given what? Y. So we shall just substitute it here, and then we integrate it with respect to what? To x. So we shall get 3 out of what? Out of 64, as shown here. Our next topic is going to be mathematical expectations. So, supposing we let x be a random variable with a probability distribution f of x, then the mean or the expectation value is the product of x times f of x. If x is what? Is discrete, is equal to the sum of the product of x and what? F of x. If x is discrete, and mean is equal to the summation between negative infinity to positive infinity of x f of x dx, if x is what? Is continuous. For example, a lot containing 7 components is sampled by a quality inspector. The lot contains 4 good components and 3 defective components. Okay? A sample of 3 is taken by the inspector. Find the expected value of the number of good components in this sample. So our solution is like this. Supposing you let x represent the number of good computers in the sample, the probability distribution of x is now going to be f of x, which is equal to 4 combination x, 3 combination 3 minus x, 7 combination what? Of 3. Remember, these are the number of ways you can select x from 4, and these are the possible number of ways you can select 3 minus x from what? From 3. And these are the total possible ways you can select 3 components out of 7 what? Components. Remember, the lot contains 4 good components, okay? And 3 defective components. There are 4 good components and there are 3 what? Defective components. And x represents the number of good components, okay? So if there is 0 good component, then there is 3 minus 0 but defective what? Components. And remember, we are sampling 3 components. Therefore, our x has values ranging from 0, 1 up to what? Up to 3. Hence, when we substitute for x equals to 0 in this probability distribution function, we shall get our f of 0 is equal to 1 out of 35, f of 1 is equal to 12 out of 35, f of 2 is equal to 18 out of 35, and f of 3 is equal to 4 out of what? Of 35. Hence, the mean is going to be the product of x times